Hello everyone. In last video we have seen how to balance a chemical reaction, and in this video we'll start with types of chemical reaction, that is second part of our NCRT. Okay, let's start. So there are four types of chemical reactions. Those include first combination reaction, second decomposition reaction, third displacement reaction, and fourth double displacement reaction. So we'll study one by one each of these reactions. Okay, see, combination reaction, it is a type of reaction in which two or more reactants combine to form a single product. Okay, in earlier video I have told you what is reactant and what is product. Reactants are the substances that combine to form a particular product or a particular substance. So these reactants can also be one or more than one with plus sign in between them. Like for example, see activity 1.4. Take a small amount of calcium oxide or quicklime in a beaker. Calcium oxide, calcium Ca and oxide O. So CaO. Okay, it is also known as quicklime. Slowly add water to this. Touch the beaker as shown in figure. Okay, quicklime, that is CaO plus water. The chemical formula of water is H2O. Okay, so quicklime with water combines to form calcium hydroxide, CaOH whole twice. Okay, so calcium oxide reacts vigorously with water to produce liquid lime or calcium hydroxide, releasing a large amount of heat. Okay, so the thing that happens here is calcium oxide combines or reacts with water, that is H2O, forming calcium hydroxide, CaOH whole twice. Okay, so in last video we also have seen about balancing a chemical reaction. So whenever you are given a reaction, you have to just balance that equation. Okay, like calcium oxide and H2O. So we have to first, we have also to have to balance this equation so that we get a proper stoichiometric amount. Okay, like and also it includes releasing of large amount of heat. So these types of reactions are known as exothermic reactions, in which heat is released, in which heat after the reaction, heat, a large amount of heat is released. Okay, in the reaction, calcium oxide and water combines to form a single product, that is two or more reactants combine to form a single product. दो और दो से ज़्यादा reactants एक साथ मिलकर एक single product बनाए, ऐसे reaction को we call it as combination reaction. Such a reaction in which single product is formed from two or more reactants are known as combination reaction. Okay, now see, do you know a solution of liquid lime produced in reaction 1.13, okay, above reaction, which is used for whitewashing walls, means this calcium hydroxide solution is used for whitewashing. That is means it reacts with carbon dioxide present in the atmosphere. Okay, so after whitewashing, when the wall is left over for 1 or 2 days or 2 or 3 days, that is, so calcium hydroxide gets react or reaction takes place between them, between carbon dioxide and calcium hydroxide, which results in formation of calcium carbonate. Okay, so the shining appearance of the wall is because of calcium carbonate, that normally is achieved after 2 or 3 days of the whitewashing. So the reaction is calcium hydroxide, that is CaOH whole 2 plus carbon dioxide CO2, giving calcium carbonate CaCO3 plus water. So water may be released out or gets evaporated because of sunlight. So hence this reaction takes place. Okay, so after this, let us take or see some examples of this types of reaction, combination reactions. Okay, so for example, first is burning of coal. Coal is carbon. So carbon burning means in presence of oxygen, O2. leads to formation of carbon dioxide. So carbon in solid state plus oxygen in gaseous form gives carbon dioxide, that is in gaseous form. Second example is formation of water from H2 and O2, hydrogen and oxygen. So this forms of water. So two gases combines to form a liquid. This is a type of if we see it as a combination reaction, but yet it is quite a important thing to understand why this takes place. Okay, so now let us see. Also, one more thing is, see, in activity 1.5, we also have observed that a large amount of heat is evolved. This makes the reaction mixture warm. Reaction in which heat is released along with the formation of product is known as exothermic chemical reaction, which I have already told you before that there are two types of reaction: exothermic reaction and endothermic reaction. After the reaction in which the heat is released, that type of reactions are known as exothermic reaction, whereas the reactions which requires heat or energy for completion of reaction are known as endothermic reactions. Okay. Other examples of exothermic reactions are like burning of natural gases. Okay, like when methane is burned, that is CH4 is burned means in presence of oxygen. Okay, it forms carbon dioxide and hydrogen. Water. So this requires, that is, heat is required to burn. It is not possible that methane kept in air will by itself form carbon dioxide and water. It requires some energy or uh, some energy, that is heat, in order for the reaction to take place. Okay, also respiration is type of exothermic reaction, that is carbon dioxide and water combines to form glucose. Okay, okay, we all know that we need energy to stay alive. We get this energy from the food we eat. So this is also a type of exothermic reaction. During digestion, food is broken down into smaller substances. Okay, this we know. For example, rice, potato, and bread contain carbohydrates. These carbohydrates are broken down to form glucose. This glucose combines with oxygen in cells of our body and provides energy. The special name for this reaction is respiration. Okay, so this is respiration. So in this, energy is required in order to break these carbohydrate molecules into glucose. This reaction C6H12O6. This is a chemical formula for glucose. When combines with oxygen present in the cells of our body, gives carbon dioxide and water. This carbon dioxide is exhaled through nostrils. Okay, okay. The decomposition of vegetable matter into compost is also a type of or example of exothermic reaction. Okay, so these are example of combination reaction, as well as not only combination but are example of exothermic reactions. So decomposition combination reactions are those reactions in which two or more reactants combine to form single product, whereas, and the second term that we have understood here is exothermic reaction. What are exothermic reactions? Exothermic reactions are those reactions in which requires energy for the completion of reaction. Okay, now let's see another type of reaction called decomposition reaction. Okay, this is, earlier we have studied about combination reaction in which two or more reactants combine to form single product. Okay, here in decomposition reaction, this name suggests that a single reactant is broken down into two or more products. Okay, so that is inverse, totally opposite of combination reaction. Okay, let's see activity 2 1.5. Take about 2 gram ferrous sulfate crystals. What is ferrous sulfate? FeSO4. Ferrous means iron, ferrous sulfate. Note that the color of ferrous sulfate crystal. Heat the boiling tube over flame of burner or spirit lamp as shown in figure. Observe the color of crystals after heating. Okay, so in this, what is the color of ferrous sulfate? It is somewhat green in color. Okay, so in this, color of the that is color of ferrous sulfate crystals gets changed. Okay, because ferrous sulfate is converted into ferric oxide. That is single reactant. Here ferrous sulfate is a reactant. This on heating this ferrous sulfate, just on simply heating, it gets converted into a number of products. Like ferrous sulfate when heated gives ferric oxide Fe2O3, sulfur dioxide and sulfur trioxide respectively. That is, this ferrous sulfate gives three products here: ferric oxide, sulfur dioxide and sulfur trioxide. Okay, so in this reaction you can observe that single reactant breaks down into simpler products. This is decomposition reaction. In simple way, just one reactant decomposes to form two or more products. Okay, here this is a decomposition reaction. Ferrous sulfate crystal, that is FeSO4.7H2O, lose water when heated and color of the crystal changes. Okay, it then decomposes to ferric oxide, sulfur dioxide and sulfur trioxide. Ferric oxide is solid while sulfur dioxide and sulfur trioxide are gases, hence they will be evaporated, whereas ferric oxide will only be retained in the that test tube. Okay, also second example, see decomposition of calcium carbonate and carbon dioxide. Okay, sorry, decomposition of calcium carbonate into calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is called quicklime. Okay, in earlier we have seen how calcium carbonate is formed. How it was formed? Calcium hydroxide with carbon dioxide. Again, see this calcium carbonate when heated, it again decomposes into calcium oxide and carbon dioxide. Okay, okay, in this only heat can be provided by two or three methods. Okay, first is by thermal, photochemical, sunlight, and third is electric. That is three types. In three ways we can provide energy or heat for a reaction to take place. That is, for decomposition reaction, if energy is to be provided, this energy can be provided in three forms. One is heating in spirit lamp or burner. Okay, second is by photochemically, that is in presence of sunlight, and third is electric uh, electric uh, electricity or electric current is provided as a form of energy for the reaction to take place. Okay, now see activity 1.6. Take about 2 gram lead nitrate powder in a boiling tube. Lead nitrate PbNO3 hold twice. Okay, this is a chemical formula. Holding the boiling tube with pair of tongs and heat it over a flame. What do you observe? So what will be observed is uh, this lead nitrate. Lead nitrate will be converted into nitric nit- nitrogen dioxide and lead oxide. Okay, nitrogen dioxide. So you will observe emission of brown fumes. That is, brown fumes are emitted. These fumes, what are? These are nitrogen dioxide. Now let's see the reaction given in next page. 2, 2 PbNO3 whole twice on heating gives lead oxide PbO, NO2 plus oxygen. This all reaction, the reaction that you are seeing in this book, all of them are mostly balanced. Almost all of them are balanced chemical equations. Okay, so while writing the chemical equation, you have to see and take care of that this should be written in balanced form. Okay, now let's see activity 1.7. Okay, in activity 1.7, this is an example of providing energy in form of electricity. Okay, take a plastic mug, Drill two holes at the base and fit rubber stoppers in these holes. Insert carbon electrodes in these rubber stoppers. Okay, as shown in figure. Connect these two electrodes with 6-volt battery or battery of any volt can be taken. Connect these electrodes to the 6-volt battery. Fill the mug with water such that the electrodes are immersed. Add few drops of dilute sulfuric acid to the water. Take two test tubes filled with water and invert them over the two carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. You will observe the formation of bubbles at both the electrodes. Okay, these bubbles displace water in the test tube. M is the same as the volume of gas collected, the same in both the test tubes. Once the test tubes are filled with respective gases, remove them carefully. Okay, what you see is bubbles are formed. This shows that the reactions are taking place. That is, with water and water with sulfuric acid. You know what reaction takes place? HSO4 minus plus H3O plus will be formed. Okay, here energy is provided in the form of electric current. Okay, now again activity 1.8. Take about 2 gram of silver chloride in china dish. What is its color? So what is the color of silver chloride? It is white in color. Okay, place this china dish in sunlight for some time. Okay, so we have to place this china dish containing silver chloride in sunlight. Okay, this sunlight, what happens? Color of silver chloride, that is whitish in appearance, will turn gray in presence of sunlight. Okay, why? Why is it? What happens? This silver chloride in presence of sunlight gets converted into silver and chloride, that is chlorine, that is Ag plus Cl2. Okay, so air energy is provided in form of sunlight, that is photochemically. Now silver bromide also behaves in the same way. Similarly, silver bromide also silver and bromine. Okay, the above reactions are used in black and white photography. Okay, what form of energy is causing these decomposition reaction? We have seen that the decomposition reaction requires energy either in the form of heat, light or electricity for breaking down reactants. Okay, so I have already told you that energy can be provided in any form. Okay, that is heat, it can be thermally, photochemically or electrically. Any form of energy can be used to break these reactants into products. Reaction in which energy is absorbed are known as endothermic reaction. Okay, so we have seen about exothermic reaction and combination reaction examples. Okay, now in decomposition reaction, some medium of energy is required. So this energy medium, this energy is fulfilled requirement. This energy requirement is fulfilled by these forms. So these are the examples of decomposition reaction in which reactants are given energy, and then these reactants or single reactant decompose to give two or more products. So we have till now studied about two types of reactions. First is combination reaction and the second one is decomposition reaction. So what is combination reaction? Again, let's revise. Combination reactions are those types of reaction in which two or more reactants combine to form a single product, whereas decomposition reaction is just opposite or inverse of combination reaction. Here single reactant decomposes to form two or more products. Okay, so this is the difference, and mostly combination reaction can be either endothermic or exothermic, but mostly this decomposition reactions are mostly endothermic reaction in which energy in form of heat, light or electricity, it is absorbed in the reaction, and after the energy is provided in enough amount, the reaction takes place. Without energy, reaction do not take place. Okay, so this here is completion of two types of reaction, and next one is displacement reaction. We'll start next displacement reaction. Okay, so before going to displacement reaction, let's see two questions given above. A solution of substance X is used for whitewashing. We have just seen just before what is X, what is used for whitewashing? Yes, calcium hydroxide. Okay, name the X and write its formula, write the reaction for substance. Okay, this calcium hydroxide, when reacted with carbon dioxide present in the atmosphere, forms calcium carbonate that is responsible for the shiny appearance of the ball. Okay, now let's see displacement reaction. Displacement reaction is mainly about electrochemical series, that is uh, more reactive and less reactive substances. So like see, let's see activity 1.9. Take 3 iron nails and clean them rubbing with sandpaper. Okay, 3 iron nails and rub them and clean them. Take 2 test tubes and mark them A and B. In each test tube, take about 10 ml copper sulfate solution. Okay, copper sulfate solution is taken, and the tie iron tie 2 iron nails with a thread and immerse them carefully in copper sulfate solution in test tube B for about 20 minutes. Keep one iron nail aside for comparison. After 20 minutes, take out the iron nails from copper sulfate solution. Compare the intensity of blue color of copper sulfate solution in test tube A and B. Okay. Also compare the color of iron nails dipped in copper sulfate solution with one kept aside. Okay. See, iron nails, iron nail. So what happens here is iron Fe, copper sulfate CuSO4. Here iron is more reactive than copper. Okay, so iron present in copper sulfate solution will displace copper from copper sulfate solution and forms iron sulfate, ferrous sulfate. Okay, so here what we understand is iron. According to electrochemical series, iron is more reactive than copper. Hence, in copper sulfate solution, iron will displace copper. Okay, and ferrous sulfate will be formed, and copper 2 plus copper ion will be formed. Okay, so see, nails of iron nail. Iron nail normally simple color. Now, but after putting it in copper sulfate solution, color of iron nail gets changed. Okay, get brownish in color. Now see copper sulfate solution, or it is somewhat bluish in color, but after this, after iron nail is dipped in this test tube, color or intensity of this blue color changes. Why? This is because now this is now not copper sulfate, it is only copper ions, because iron has displaced copper from copper sulfate solution. This is because iron is more reactive than copper. Okay, so you see, why does the iron nail become brownish color and the blue color of copper sulfate solution fades? Because this reaction takes place. Fe in solid form plus copper sulfate gives iron sulfate or ferrous sulfate plus copper. Okay, in this reaction, iron has displaced or removed another element, that is copper. Okay, removed copper from copper sulfate solution. This reaction is known as displacement reaction. Other examples of displacement reaction are zinc in copper sulfate solution gives zinc sulfate and copper is released. Iron in copper chloride gives lead chloride and copper. So this shows that zinc, iron, lead, these are more reactive than copper, and because of this reactivity difference, this displacement reaction takes place. Now fourth type of our reaction is double displacement reaction. Okay, In earlier, that is displacement reaction, we have seen only one of the ion is displaced, but here we will see both, that is double displacement takes place, double displacement takes place. Okay, let's see activity 1.10. Take about 3 ml of sodium sulfate solution in test tube. In another test tube, take about 3 ml of barium chloride solution. So what happens? Sodium sulfate. What is the chemical formula of sodium sulfate? NaSO4. Valency of sodium is 1, whereas valency of sulfate is +2. So Na2SO4. Okay. You will observe that white substance which is insoluble in water is formed. This insoluble substance formed is known as precipitate. Any reaction that produces a precipitate is known as precipitation. So one more type of reaction that we have studied is precipitation reaction. Earlier two was exothermic reaction, endothermic reaction, and again this precipitation reaction. What is precipitation reaction? Precipitation reaction is type of reaction in which precipitate is formed. Okay, like see sodium sulfate in presence of barium chloride. Barium sulfate and sodium chloride is formed. Why this happens? And what is this precipitate? This is barium sulfate. Okay, so this barium sulfate and sodium chloride is formed because of the change of or exchange of ions. Okay, displacement reaction takes place because of exchange of ions between the reactants, and hence called double displacement reaction. So in displacement reaction we will only one is displaced, whereas in double displacement exchange of ions takes place. That is, both the ions exchange, maybe due to their valency or their reactivity. It is mainly based on their reactivity difference, due to which displacement do take place. Okay, so here comes the end of all four types of reactions. First is combination reaction, second is decomposition reaction, third is displacement reaction, and fourth is double displacement reaction. So what all we have seen is, along with these four types of reaction, we have also seen three more types of reactions. The three types of reactions are exothermic reactions, endothermic reactions, precipitation reactions. So these things. What is exothermic reaction? In which heat is released in the reaction. Endothermic reaction in which heat is absorbed in order for the reaction to take place. And in precipitation reaction, precipitate is formed in the reaction. Okay, so four types of reaction, and again in that three types of reactions we have seen. Before this, in part 1 we have seen how to balance a chemical reaction. Okay, so this is about the types of reactions. Okay, now the last portion of this chapter includes, have you observed the effect of oxidation reactions in everyday life? What is oxidation? That is addition of oxygen. Okay, so here we see about two types, that is corrosion and rancidity. What is corrosion? That is, corrosion is a term given mostly for iron articles. See, you must have observed that iron articles are shiny when new but gets coated with reddish brown powder when left for some time. So what happens here? This iron reacts with oxygen, okay, and forms some brown powder or reddish brown color powder, okay, called as rusting of iron. And the scientific name given for this rusting of iron is corrosion. Okay, some metals also get tarnished in this manner. Have you noticed the color of coating formed in copper and silver? When metal is attacked by substance around it, such as moisture, acids, etc., it is said to corrode, and this process is known as corrosion. So, what is corrosion? Corrosion is when a metal, only metal, is is affected or attacked by a substance, that is moisture, air present in the environment. They are they are said to be corroded. and the process is known as corrosion. The black coating on silver and green coating on copper are examples of corrosion. Also, reddish brown powder formed in iron is also an example of corrosion. But there are some side effects for corrosion. Like, see, corrosion causes damage to car bodies or mainly things made up of metals, like damage to car bodies, bridges, iron railings, ship, and to all the substance made up of metals, especially those of iron. Corrosion in iron is a serious problem. Every year, an enormous amount of money is spent to replace or damaged iron. Okay. Now, rancidity. Rancidity is also an example of oxidation only. In means when a food is kept for longer time. Okay. When fats and oils are oxidized, that is, they are oxidized, they become rancid. That is, their taste or smell somewhat gets changed. Usually, substances which prevent oxidation are added to foods containing fats and oils. Okay, so what is the method to prevent oxidation in food is antioxidants. Okay, these antioxidants slow down the process of oxidation. Also, for example, chips manufacturers usually flush bags of chips with gas such as nitrogen in order to prevent oxidation. Also, what are the methods with which corrosion can be eliminated? There are a number of, like painting, like paints. Paint prevents these metals to get attached or to come in contact with the moisture or environment present in the atmosphere. So when the metal is not exposed in the environment, the process of corrosion slows down. Okay, until and unless this metal do not come in contact with the atmosphere, oxidation do not take place. So these are some methods by which we can also prevent corrosion or oxidation in other terms. Okay, hope you have enjoyed this chapter. Let's This is the end of chapter 1, class 10th NCERT, that is chemical reactions and equations. Thank you.